Welcome to a new test and teardown video. This time it's a very interesting CO2 measurement instrument, and I think the company is called Distillers Gasminder instrumentation, and then carbon dioxide detector. Type, is it EI1? So there's a sounder, and I can see some indicators and a display. I don't know what else we can see here. An IC, mains entry, and a red and a black wire. What is that for? Probably a battery, maybe? I think I'm gonna put a voltmeter on this and see what happens. And then power it up. Probably it's gonna suck in some air. I try to shake it carefully, but it seems like there's loose parts in there, but I think it's probably a part of the pump. So it's maybe okay, but I think let's just power it up and see what happens, right? What are we afraid of here? There's a little hole. Ooh, trimmer. And this is maybe zeroing, right? Yeah, it looks like there's some sort of a wall mount bracket we are missing. And then you slide it in like that. So it's definitely supposed to be mounted like that. Really funny wall mounting style. So let's just try and power it up and see what happens. Oops. I hear some humming. 8 watts. We don't get anything out here. Oh. So this is an analog kind of video, or analog output. It's not related directly to the output, so this is 0.0% CO2. What do I do? Ooh. So I push and hold this. And then what? What do I do? Aha! That was a 0. Oh! Listen. It's pumping air. Oh yeah. I can feel it. How do I get some CO2, huh? I don't really have any CO2 in its pure form, but I got another idea. Let me try and blow directly into the hole here. It's probably gonna look a little bit weird from your angle here, but let's see if that is. If I take a big Whew. See, I can get it up. That was funny. So yes, it is definitely measuring something. I wonder what kind of level I need to make it alarm. Maybe I should bring this to one of my meetings where everybody is sitting and falling asleep. Haha, that could be cool. This is just so cool. So this is how you disassemble it. So this was the sensor input. Was this like this, right? So you see some hoses. And the bottom part is a power supply, but it's also interfacing to the top part with power, and then there's a regulator. But look at that! In here is the electromagnet pump. That is a very cool way to do that. So when you slide out that part, then you get the pump kind of part. Wow, look at that, it's smart. So, dibbity dibbity dibbity. And this moves air in and out here, and then it probably goes through some sort of sensor thingy. Where is that? Okay, so we need to figure out how to pull this out. It is very, very nice. US patents, yada yada yada, and then it's tested in '86. I'll see if I can take it a little bit more apart. What we got? 1, 2, 3, 4 circuit boards, and I guess we can slide everything out. Maybe if I just release this piece of metal here. I think I figured this out. I removed the top. So it should slide out with a little bit of whoa. That is a lot of funky stuff. I hope I will be able to assemble this again. Alarm fault. Oh, this is the classic analog readout chip, right? So that is not a connector. And then there's an EEPROM. Really? That is a little bit funny. I think we got analog to digital converter, and then the EEPROM is making the ratio. It says actually here ratio linearizer board. So of course it's done with an EEPROM. How sexy is that? Yes, AD converter, EEPROM, DA converter, man. That is super sexy way to do it. It's completely configurable and programmable. Ah, don't you love it? And then what? What else have we got? That is the sensor thingy. Okay, let's get this. And power supply entry, and this little sexy pump. So all the goody stuff is in that thing here. And silicone hoses and whatnot. Ooh, temperature compensation. Or this is just a regulator that was put here. See? This is just a standard voltage regulator, and that it's only using this one for heatsink. That's a little bit funny. This is very heavy, this sensor. Oh, it looks like we can unscrew the lid here and have a look. And definitely here in the bottom we got some more electrical connections. Also here We got some op amps. Oh man, I don't know what the heck that sensor is right now, but we're definitely going to figure that out in a few minutes. It's a little bit annoying with the cables here not being connectors. So everything here is just one big folding around kind of thingy, right? Okay, this one can go through here, and then we can untangle. Super cute, this pump. Oh, it's a little hinge, dibbity doody. Yeah, all the front end preamp detector board, it says. Maybe I should go and have a look at some of the ICs. Maybe we can get some date codes. We know that this was tested in 86, but maybe we could figure out some more. Yeah, I've of course been able to Google this product and Google the sensor and all that kind of stuff. So yeah, I can actually tell you how it works. That is so cool. Yeah, so we got this AD converter and DA converter and the conversion table for making this accurate. And this is of course also how you digitally calibrate the whole thing. So this is of course the CO2 sensor, and this the pump makes sure that the atmospheric air goes through the chamber and out again, so it's always filled with the right kind of air. In here we got a little light source. So this is infrared light, and this light that goes up here and hits two different sensors, or at least there are two different filters on the two sensors, and they go to two different op amps, and then they go to an active filter. So I believe they pulse the infrared source or the light source on and off, and then they measure the light that is infrared and the light that is not infrared, because CO2 air molecules, they are very easily absorbed by 4.3 micrometers, or was it like that, right? The wavelength. So it's super long infrared, and so it's just a light detector and some filters and some conditioning of the filter kind of stuff. So yeah, there isn't any magical fantastic stuff in here. We could definitely just unscrew the lid and have a look inside if it's not glued or secured in any way, and then we could probably look directly down to the sensors. I don't think I can unscrew this with my fingers, but it could be fun to have a look in here. I just tried with some tools. There's just no way I can open the sensor. That's a little bit annoying. It could be super fun to have a look at that. But anyway, what are we going to see? A little reflection, and then it goes up and down to create some more results, right? The longer this is, of course, the more sample you have, right? Of course, it's going to be more and more sensitive. And what else can we see here? So that is the MF10CN from National. So this is a digital filter, and obviously they are oscillating the sensor on and off, and then measuring the difference via filters, and this way obtaining a better signal to noise ratio or better sensitivity. It's probably also calibrated on these to create a good rejection, right? I'm a little bit annoyed about the lack of connectors here, so can't really. So it says 85 on the codes. Yeah, see here. 40, 60, op amps, DA, AD. Could be fun to read out the calibration table. And that's just the analog to read out. Oh yeah, about the power supply thing here. There isn't really a lot going on in here. You see the transformer down there? It's mounted on the bottom, so you need to be a little bit of a surgeon to pull this out. But of course you could do that if you really wanted to. But there isn't really a lot else to show here, except this one is driven by mains AC, making the pump vibrate. It's a little bit funny to see those adjustments. Why did they do that? And then alarm relay, so you have an alarm normally closed, normally open, and you also got an analog output that says milliamps. So that is what's driving the external remote stuff here. That is all there is to it. So we can easily remove this. We don't need that. And then play around with this unit a little bit more. I think you should be happy that you can't hear all the stuff that I've just been yelling and screaming. I mean, assembling this thing again is some sort of a 3D Tetris, so I can't really... I don't know how many times I had everything in and out here a few times. Because, oh, you need the wires this or the hoses this way, and then this cable, and then you need to slide everything in. Oh, you have to have this plastic here. Oh, it needs to stick through this, and then slide this in, and then lock everything like this. And then I think I am about ready to slide it in for the 10th time or something like that. And then, oh, they need to go in a certain way, and that slides in last, right? So here's the idea to test the CO2 alarm. Look what I found. A fire extinguisher, and that one is CO2. So I bet I can just pull this safety thingy, and how about we grab a little bit of let's see if we can grab a little bit. So now this bag is full of CO2, right? At least that is, what do you think? Oh, even look at that. So now, see how sensitive it is? Just a little bit. This is 100% CO2, obviously, right? So let's just let this little bit of this escape. We should be able to get an alarm in a minute. How about we just blow it directly into the sensor? Oi! See, an alarm 4.8. And then if I remove my CO2, let's blow some. So we just blow a little bit of fresh air, and then it goes back again. Haha! I figured out a little bit more about this unit I wanted to share. I thought in the beginning this button was a reset kind of, or calibrate kind of things. This one is the push to show the alarm level, and then this little trimmer, there's a tiny little trimmer in that hole. I don't know if you can see that, but if you push this and adjust the trimmer at the same time, you can adjust to a new alarm level. I just changed it down to 4 instead of 4.8. So that is my new alarm level. So that is what it's all about. So how are we going to figure out if this CO2 sensor is actually measuring the correct values. I came up with a really, really funny idea. So first, we're going to fill a bag that is 4 liters with normal air. We're going to close it like this. Then we estimate the volume is about 3 liters because about 1 liter is wasted up here in the top. At least this is what we estimate. Then we have another bag that is empty, and then we try and fill this. Oh shit! That was way too much. The idea was to do it like this. This is now 100%. Okay, so the idea is we take a syringe, stick it in here with the 100%, and then we suck out 60 milliliters of 100%, and then we put in the 60 milliliters into our clean air. Like this. Is it in? Mm-hmm. I can't see. And then we hold it real tight, like this. Yes, be careful. I hope it's not broken here. Then we shake it a little bit so it's mixy, mixy, mixy. And then we go this way into the tester here. So let's pretend we had 3 liters and I put in 60 milliliters. I would estimate that the concentration should be around 2%. Now I'm trying to force it into the test chamber, and let's see if it stops at about 2%. Is it mixed? My volume was not 3 liters. It was probably a little bit more, right? So it's not the highest accuracy of science. Only 1.5. Okay, so it's not super accurate, this method, but what the heck. It's definitely not defect, right?